Let's go. Okay, so uncertain system 01. This is what are we doing today? Okay, so where were we? We were basically playing with these, and now I have to just do a big rewinding of this. If I run that, what I was essentially getting is the input was, so you have the input sequence, we are tokenizing the input sequence. So we're doing these word by word. Then we're printing these, and the quick brown fox jumps over the lazy duck. Exactly, so there's 9 tokens. We're trying to basically think about what was this max length parameter here exactly, because if we were setting these to less than 10, then I was not getting the full. So I was trying to understand just with a very input sentence, so just a very simple example how the input encoding works, right? So the architecture is here. I can actually put it here, and we're now just barely getting into what so we built the input embedding, we built the multi-head attention, at least just the AI. I mean, Ghostwriter did it, but we're trying to now understand how this works, and this is going to be the biggest the monster here later. But let's see. So we have this, and then we essentially have the characters. So we're converting the tokens to padded one-hot vectors exactly. So what I'm not so sure about this is, I guess the tokens. I keep forgetting what one-hot vectors really means. Ghostwriter. So model. So what did that mean? They used to represent the input sequence. So the one-hot vector is this whole thing, which is now padded with zeros because we're just saying, well, we have like this is the length of the sentence. So we can lower these to 20 and then run it, and we're getting some extra zeros, but not so many. The position, okay, so one-hot vectors are the type of encoding where a single token is represented by a vector. That's what I'm getting confused, because here's what it's saying. So what it's saying here is it's saying that one-hot vectors are a type of encoding where a single token is represented by a vector that has only non-zero elements in it. And I believe that we are now seeing these just numbers because the D model is 1. If I set the D model to 2, what's going to happen? And I think then these are the one-hot vectors. So has anything changed? The quick brown fox jump. Is this correct? So the model is used? No, the model is not used actually to the vectors. So for each token, tokens. This is what, no, so these are the tokens, obviously. This is what we want to do. So we want to print the input IDs here. That's what we want to take a look at. So this is, I want to take a look at, so here in this first step, so this is basically input IDs. So, or this is one-hot vectors, I would say. One-hot vectors. Hots, George Hots. No, one-hot vectors. And it's input IDs. Input IDs. So is there a way to, yeah, just to separate it a bit more. Yeah, okay, cool. So I don't think that is right, because essentially we just have two one-hot vectors, and this is where so you take a look, you go through the tokens, and then you so can you simplify this line? Can you simplify this line so it's easy to understand? I mean, explicit, whoops, maybe. So what it's doing is, I mean, input IDs for each token. Yeah, okay, but that's the problem. It's treating. That's what I don't understand. So this sentence is essentially treating each sentence as a token, and that's not what we want. So in the context of transformers architecture, because I have to be careful, because you know, this could be, the implementation could be wrong. So that's kind of what makes it difficult, right? But also what makes it like an actual good learning experience. And so in the context of the transformers architecture, are tokens the individual words or full sentences? I think they are the individual words, right? Yeah, or even sub-word units. Because in line 14, so you're splitting as in sentences, and then for each sentence, okay, so, maybe there's something wrong here, as in like, I think sentences actually okay, so let's stop here for a second. So this should be an array. This should be an array of arrays, shouldn't it? Like if I go here, tokens, and here tokens, 1 is 2 essentially. Run. Yeah, that's, and I think that's a problem. That's not what the code is meant to do, is it? I think it's supposed to essentially do. So for each. Yeah, that's definitely wrong. And so he is splitting. That's fine. So the tokens is like first, in the first step, you basically, you know, if I have a second sentence here, what is going to happen is that is going to have the two sentences, but then we still want to go one more dimension, and in input 2 there should be for each I think that's wrong. So here we should just have for each sentence then an each token, so for in tokens. So for each sentence in tokens, I think that's not doing what it's supposed to do. So in line 15, is this code supposed to break down every token into its own array, right? Of the model length. Okay, so no, okay, so it simply creates, maybe I'm asking the wrong question, right? But it simply creates a nested list of individual tokens for each sentence. In tokens, the result expression is equivalent to the following double loop. The resulting tokens list is a nested list where each inner list represents individual tokens for a single sentence. For example, if sentences contains 2 sentences, but that's something that you already unless the purpose of these is just to do the lowercase. Okay. Fine. Let's assume this is fine. Let's assume this just does the lowercase, and this splits that into sentences. Input tokens. Okay, print the tokens. So here we have the tokens, 2 sentences. Okay, and then the 1 hot vectors. But still, so in the implementation that I have, we're treating each sentence as a token instead of each word. And I understood you said each word or subword unit is what should be represented as a token. Can you fix that? But this is already what it's doing. Okay, so this splits each sentence into individual words to create a nested list of tokens. Okay, yes, fine. Where each inner list represents the individual words in a single sentence. Okay, that's correct. No? Yeah, okay, so fine. Maybe I asked this wrong. So each word is exactly, but then so the next step is to convert each word token into 1 hot padded vectors. But in our code, we are transforming each sentence instead of each word. Can you fix that? Okay, so I think that is definitely convert tokens to added 1 hot vectors. Yes, I understood that. Each value is the ASCII of the word, the ASCII of the word. So maybe that's what the positional encoding is supposed to do. So maybe that's fine. Maybe I'm just stupidly Because what positional encoding does is, this is when it's adding the D model. So I think maybe that is correct. So it should just So let me think. So this might just be correct, okay? So this means the one-hot vectors are essentially, that's the problem is when I ask what the one-hot vectors are, so it tells me the one-hot vectors are, so then one-hot vectors for each one-hot vector represents a sentence or a word or a token or a word. Yeah, that's the point. Okay, whatever. Tokens to padded one-hot vectors. It's fine. Why are they called one-hot vectors? I think I asked already, but I forgot. One of these are called that because they contain exactly one hot or on element, and all other elements are off or called. In the case of tokenization for natural language processing, each one hot vector represents a specific word in a given vocabulary. The vector has the same length as the vocabulary size, and the position of the hot element corresponds to the index of the given word in the vocabulary. For example, contains the word dog, cat, and elephant, and the one hot vector for cat would be, that's my point, and here we just have the ASCII code. Okay, so we have, no wait, of each letter actually we have, yeah. Exactly. Ah, okay. Well, the categories are the different possible characters that can appear in a word. Okay, so the current partition word, each word as a sequence of ASCII codes. For the characters in that word, the resulting vectors are not true one-hot vectors, in the sense that they do not have a single hot element per vector. However, we can still think of them as representing categorical data, where the categories are the different possible characters that can appear in a word. In practice, using ASCII codes to represent words is not common in NLP because it can be very inefficient. Instead, word embedding algorithms are often used, which can represent words as dense vectors of real numbers. But where does this take me? I still feel that this is wrong and that we should have a vector per each word. You know what I mean? I have the feeling we're missing some like a dimensionality here. Shouldn't we have, okay, so then we should have each word wrapped into a nested array, and the current code doesn't do that. Can you fix? I do think that's what we have to do. And I was thinking, you know what I mean? Like here we just have like one like the sentence is just the you have the collection of all the numbers in here, and we should just basically have yeah. Let's try again. To represent the input sequence as a list of nested arrays, each nested contains exactly. Okay, so what do we have here? So we have exactly, we have that extra step in here. So we have that extra step, input IDs. Okay, and then that's not here. Let's just copy the whole thing and paste it here. So let it run, see what we get. Okay, now it looks better, but there's a problem with the dimensionality. Oh yeah, because I actually, it's fine. I had that commented out. So now we have each word is basically like that. Yeah. But now, and my assumption isn't now basically isn't max length. That's I'm again. I hope I'm doing the right thing, but I understand something. I'm not so sure that the ghostwriter is telling me the right thing. So, and shouldn't each. So now I want each one hot vector to be, because essentially we are processing tokens. We don't really care about the length of the sentence, do we? At this point, so we want. What needs to be padded by zeros is the word vectors, not these stuff here, right? So where do we have the max length? Max length is in here. So I want each word vector to be padded with zeros, so that each vector has max length. I think that's what we want. And then modify these so that it prints each word vector and at the front row. Okay. So just so we have it like nicer, and then we run it. Oh god, input token. Oh, but sorry. I think I first should copy all these, then I should copy these. So essentially, it almost feels like what you have to get good at is find the right balance between iterating iterating with ghostwriter to get this stuff done. It's faster to iterate sometimes than to just try to understand, what went wrong. Okay, now we're talking. So, and then I want the length. I also want to just basically yeah, but it's all the same, exactly. So what about these here? Padded tokens. Okay, that's fine. So what we want to do now is we want to split the percentage individual word vectors, padded tokens. So I don't think that we need that, do we? if I comment this out, what do I get? Yeah, exactly. So if I just print input IDs, okay. Now I have a list, an array of arrays, which makes more sense. It's kind of like a, so it's like an actual tensor, right? I'm having a list of basically of words, but then each word is kind of, it's got like its own then dimension with, which is basically kind of, in this case we're using the ASCII representation and then padding the rest with zeros. I think that's what makes more sense. Now, what comes next? So the next thing is convert input IDs to NumPy arrays. So what is that? Okay, so can we now convert seems like current code and line doesn't work well. Okay, so we copy that, and then what is it that we have here now? So now we should basically print in NP format. Okay. Let's see. Look good. Nope. List index out of range. Yep. Okay, now it actually nailed it. It's line 35, and it should just be these. Was very cute. it's very funny because it really kind of behaves like a human, right? So the human would just go and implement stuff, and then it's like you're sure that it's going to work. Then you test and it doesn't work. It's like, oh yeah, I know what the problem is, and then you kind of keep fixing that iteratively. it's very odd. So list out of range. What is it going to say now? Okay, so padded tokens. That is out of bounds. Just line 27. That's what's wrong. But essentially, okay, so this is to Are you sure? Are you sure? Okay. And then it's making me change that back to what it was. I'm not so sure I want to do these, because if I do these, and then change that back to these, it doesn't break anymore, but then yeah, it's giving me the same error. Let's just make that again simpler. One sentence. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's fine. Okay. I think that's definitely wrong. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's correct. Okay. All good. Each word then, So you have tokens, and each token has characters, and then each character has this representation exactly. And so what is it? And now it's complaining about these. But what is it trying to do here? So convert the input to NumPy arrays. It's asking me now to change a line that doesn't exist. No, it exists here. Add padding to each vector. No, that's all fine. That's all fine. Let's give it another. So let's try to debug this ourselves. I think there's something off here. So number of sequences is the input IDs. Exactly. So padded sequences essentially. I think that is the so number of sequences. Let's just start printing some of this stuff. Not console log. Oh my god. Print. And then print padded sequences. So this is fine. It's 9 because we have 9 words. 1, 2, 3, 4, 5, 6, 7, 8, 9 words. And then for padded sequences, is what it's doing is 2, 3, 4, 5, 6, 7, 8, 9. It's doing 8. It's creating 8 sequences. 9 sequences, right? So 3, 6, 9 sequences, 1 per word. And I think that is the problem, is that it's doing I don't know why is it doing it like that. I think that's stupid. I think you should just basically okay, so I think that's stupid. That's not doing it like, because that's pre-creating a structure. Cannot you just convert can you so that you iterate over each you know, sort of each sentence word, and then just convert each word array into a NumPy array. Casting directly, I guess you could say. I'm not so sure this reshape here. No, pad, so input IDs. Okay. Yeah, that's odd. I don't know why it's doing this reshaping. So what if I don't do the reshape? In NumPy format. Okay, that's also not correct. It's trying to do a in sentence. No, not in tokens, but in input IDs, right? For sentence in input IDs, exactly. For sentence in input IDs, this is for how for word in sentence. That's so. Let's trash these. It just took literally my. Okay, so how do we get that? How do we get that straight? What we want to do is we wanna basically transform each into each of these padded tokens thing here, not this one though. That's maybe what I should have done first. Each of these elements, input IDs. Padded tokens. Maybe what I should do, add padding to each word vector. Isn't there a way to just cast a whole, like a tensor, a list of lists? Okay, so isn't there a way to kind of cast an entire nested list of lists into a NumPy tensor? Into a NumPy tensor? Exactly. Yeah. So for dimension 3, I think that is the easiest thing to do. That's what we have, exactly. That's what we have. Yeah. So I think that should actually work. So sometimes it's just asking the right thing. That's the, like if you ask convert this into an NumPy array, I think that doesn't capture, like a human understands that better. But that is where the problem is. It's like you have to find the way to ask so that it understands better what is it that you're trying to do. So I think that should make it, because that's what we want. So we have these, which is basically a list of so a list, right? And then there's a whole. So there's a list of lists. So we have a list. And then there's essentially a list of lists of lists, right? So these are essentially each word. So, and here you have 3 sentences, but in our case, we just have 1 sentence. Yeah, exactly. So, and they are on top of that padded. But that's like, I think that's what we want to do. So we want to do these with input IDs. So in input IDs, and then print that. So let's see if that works. Yes, that works. That works, exactly. And if now we add basically second sentence here, then we have that, then it breaks. Why? Okay, so maybe, yeah. Then we should also pad each sentence. Like if I add the same sentence twice, so it's exactly the same length, is it gonna work? Okay, that's the next thing that we need to understand. No? So okay, it seems like that's the next step, but I think I have to stop here today actually. Anyway, we've made a bit of progress. So I think we fixed that. We now need to basically do make it work for one sentence. Do we also need padding there? We probably need padding because essentially that's the whole thing, right? So we need to make sure that everything has like a nice regular structure so that we can do matrix multiplication later on. So the sentences might also have like a max length. So do we need also to pad each sentence with respect to the amount of words? Yeah. Right, exactly. Okay. That's probably the next thing to do. And then once we have all these, then I think that we have a clear structure where we just have a tensor that represents each sentence. Yeah, but essentially, why are we doing multiple sentences? Cannot we just do one sentence? I don't understand. Let's just stick to one sentence. Do we need to have multiple sentences? Input sentence is one sentence. Why do we need multiple sentences? I don't understand that. Actually, that makes no sense. That makes no sense. That makes no sense. So I think that's the problem. We should just stick to one sentence, right? Sentence. Rewrite these two. So rewrite these. That's what we, and I think that's another mistake. So yeah, I think that's the only thing that we need to do is just these. So let me remove these to do that we added here. Where did we add the to do? Where's the to do? Huh? It's no to do. Sentence. So what happens now? Shouldn't you just split exact? No, that's wrong in here. Okay. Yeah, I'm time's up for today's session. But I think we need to do that. Where was the to do? So have I just? Did I write it somewhere else? Where have I written my to do? I thought I had a to do basically written somewhere here. Am I just missing stuff? Anyway, so we have the sentence. This we need to fix. Padded tokens, input tokens, and then here, this is what we need to basically change. No, this is what we need to change. Let me try. Okay, I just wanna get it into a clean. So split the sentence into an array of words. So rewrite so that we split the sentence into an array of at least of words and a list of words where each word is a list of characters. Exactly. So we want, so let's do this. So we do the word sentence. Yeah, but that prints sadly the characters, right? Oh, no, okay, that's all. Good. Actually, that's pretty good. Okay, split the words. Then we do to a list of characters. Okay. Okay. Ah, there you go. Cool. So we have. Okay, sounds good. So we have basically the these. Then we add the. Then we pad them. Pad the tokens. Okay, cool. Then we pad the tokens. And then essentially, yeah. Now each of these represents 1, 2, 3, 4, 5, 6, 7, 8, 9 a word. Exactly, the 9 words. Now we got it. Cool. Now we can leave it here. I'm happy. So we have basically now a list of the words. So exactly, it's 3-dimensional, right? So the list of words, and each word is a list of characters, and each character is a 0 padded number. Exactly. And then we're essentially now we're here. Yeah. Okay. Position coding. I'll remember that. Anyway. Thank you, and see you next time.